Hello guys, welcome to our calculus online class. So today's topic is optimization. So let's begin. In your opinion, what is optimization? The word optimization comes from the same root as optimal, which means the best. So if you are optimizing something, you're making the best out of it, right? But in calculus, optimization problems will ask you to maximize or minimize some quantity. For example, finding the maximum or minimum values or areas. So let's move on to the step of optimization. Firstly, identify all quantities or possibly make a sketch of it. Second, develop a primary function that will convert from the problem description of each situation into a function. Number 3, write down objective functions for those quantities that you are going to maximize or minimize. Sometimes equations may come from geometry's formula. Number 4, plug the primary function into the objective function for making it contains only a single variable. Feel free to pause and read. Number 5, differentiate the function before, then setting it equal to 0. Plug in the answers from previous functions for finding the values of each variable. And lastly, plug in those values into the objective function and getting the answer. So let's try some problems. Our first question is to find two positive numbers whose sum is 60 and whose product is maximum. So let's begin by writing down our two functions. Let's say that the two numbers are a and b, so the sum is a plus b and replaces the sum by 60. So we now know that 60 equal to a plus b, right? And another function is the multiplications of a and b or product functions. So we want to make this function contain only one variables. In order to solve, making the first function by solving for a or b, let's solve for b by subtracting both sides by a. Then we now know that b is 60 minus a, right? Replacing b by 60 minus a in the product function, then we will get 60a minus a squared. Differentiate it and then set it equal to 0. A will equal to 30. Plug 30 into 60 minus a, you will also know now that b is also equal to 30. Finally, plug both values of each variable into the product function and the answer is 900. So let's move on to another questions. Let's do the one with a drawing. Find the dimensions of a rectangle with a perimeter of 100 feet and whose area is minimum. First, draw a rectangle. Set the width of the rectangle is x and the length is y. Then writing down two functions. First one is the perimeter. The perimeter is equal to the sum of all sides, so it is going to be the sum of 2x plus 2y. Then the function is 100 equal to the sum of 2x and 2y. In that case, we can divide both sides by 2 for solving x or y and get the function of 50 equal to x plus y. Let's solve y then. So y will equal to 50 minus x. The objective function, this one, is an area equal to the multiplications of x and y. Plug in y and we will get area equal to 50x minus x squared. Differentiate it and set it equal to 0 again. Now we will know that x is equal to 25. Then replacing x by 25 in the functions of 50 equal to the sum of x and y. You will know the values y is, which is also 25. Lastly, plug in both variables into area functions and the answer is 625 square feet.